Today we're going to look at the last little section on conics. You know, we're going to look at hyperbolas. We've talked about parabolas and ellipses, and we'll look today at hyperbolas. So, what is the standard form for a hyperbola? The standard form for a hyperbola with center HK is given by x minus h squared over a squared minus y minus k squared over b squared equals 1. And this is if the transverse axis, if it's horizontal. And we'll talk about what that means. The other form, y minus k squared over a squared minus x minus h squared over b squared equals 1. And this is if the transverse axis is vertical. Okay. So, the vertices are A units from the center, and the foci are C units from the center. And we now have the relationship that C squared is A squared plus B squared. Okay? Different than from the ellipse. Okay? That's a different equation from the ellipse. And if our center is the origin, then these equations break down to x squared over a squared minus y squared over b squared is 1. And this one breaks down to y squared over a squared minus x squared over b squared equals 1.
Ellipses with C from the center, right? Ellipses.
No, this was different. C squared was, I think, a squared minus b squared.
Oh, yeah.
But the vertices were still A units from the center, and the foci were C units from the center. That was still the same. Okay? But notice the difference here. Here, our A is going to go with the positive. Okay? B squared goes with the negative. What they switch around is the x minus a squared and the y minus k squared. And of course, this is negative, whereas with an ellipse, they're both what? Positive. So let's look at some pictures of these two cases. We only have two cases here. The first case, okay, suppose we have, I need to draw my ellipse a little better than this. Okay. And let me draw a little better so that the center does not seem to be the y, the x-axis. Let's say this is our center. Okay. These points on the line are the vertices Okay? The foci are somewhere out here on the other side of each vertex. This is the foci. That's a focus, and this is a focus. Okay? And if we draw a dotted line, that's called our transverse axis. And the transverse axis here is horizontal. Okay, so if my center is HK, okay, my vertex is what? A units from the center. Then that makes this vertex have coordinates H minus A, comma K. And this vertex have coordinates H plus A, comma K. And my focus is C units from the center. It makes, my foci are C units from the center. It makes this focus H minus C, K. And this one what? H plus C, comma K. Okay? So this is if my transverse axis is horizontal. Let's look at the next situation. Where my transverse axis may be vertical. Okay? And this is my center, HK. And this is a vertex. This is a vertex. Focus, focus. So there, now my transverse axis is vertical. Okay? So again, the vertex is A units from the center, but since I'm vertical, I'm going to be doing plus or minus on that K. So this vertex will be H comma K minus A, and this vertex will be H comma K plus A. The focus down here will be H comma K minus C, and this one is H comma K plus C. Okay? So if we know that center, and we know, find the vertex, pretty much you can draw a sketch. So let's look at some examples dealing with the hyperbola. We want to find the center, vertices, foci, and we want to sketch. Suppose we have x plus 3 squared all over 144 minus y minus 2 squared all over 25 equals 1. So which situation am I in? Is my transverse axis horizontal or vertical? And how can I tell? It's horizontal because my x term is what? It's first, so it's positive. So transverse axis horizontal. So this means that A is what? 12. A squared is 144. And B is what? 5. Which means I can find C. C is going to be the square root of what? A squared plus B squared, which is the square root of 169, which is 13. Okay? Which means I can find my vertices, because where the transverse axis horizontal is what? H minus A. Well, what's HK? Let's find the center. Center is the point HK, X minus H, and Y minus K. So this is my HK, negative 3, 2. So my vertices, H minus A, so negative 3 minus 12 is negative 15, comma K. And what? H plus A, negative 3 plus 12 is 9. So those are my vertices.
How did we use this sort of?
Okay, because by looking at the equation, my x minus h is first and it's positive. If it's second and negative, then it's vertical. Look at the foci. It's h minus c, so negative 3 minus 13 is negative negative 16, 2. And then my what? H plus C is 10, comma 2. Okay? And then it says to sketch. Okay? So I need to at least go out negative 16 on the X to 10. And then up to 2. So let's see if we can sketch this. We're going to do this. We'll do 5. 5, negative 5, negative 10, negative 15, negative 20. 5, 10, 15. And then we'll do 5 up. So my center was negative 3, 2, which is about here. Okay. My vertices, negative 15, 2, about here. And 9, 2, about here. So I know this is going to go out this way. Okay. My foci, negative 16, 2, and 10, 2. Okay? My hyperbola. Another example. X squared minus 9y squared plus 36y minus 72 equals 0. And I need to do some completing of squares to make that look like the standard form. Okay? Now, how do I know which one to make it look like? First and the second one. Well, my x squared is positive and my y squared term is what? Negative. So that tells me there. As a matter of fact, I don't have any other x terms other than x squared, do I? Which means I'm not going to have to complete the square on x squared. Okay? Because there's not an x term for me to take half of, is it? Let me take my constant over. But now I look at these y terms. And in order for me to complete the square, I need my y squared to be what? Positive. So I need to factor out that negative 9 from those two y terms. So now I complete the square. Half of negative 4 is what? Negative 2. And negative 2 squared is positive 4. But I didn't add positive 4. I added negative 9 times 4, didn't I? Which is what? Which means I need to go over here and do what? Subtract 36. And this becomes y minus 2 squared equals 36. Okay, that's almost of that form, but I need a what? A 1 on this side. So let me go through, divide everything by 36. So I have x squared over 36 minus y minus 2 squared over 4 equals 1. Okay? So what is h comma k? 0 what? 0, 2. Because it's just x squared. It's like x minus 0 squared. Transverse axis is what?
Why do you divide by 36 should be the third part?
Because standard form has a 1 on that side. So we have to make this 1 by dividing everything by 36.
Don't you have to subtract 36 from 72 first?
Yeah, 72 minus 36 is 36.
Oh, sorry.
My transverse axis is what, y'all? Horizontal. Which means I'm in this case here. I can find my vertices. They are what? X minus A. Okay. So what's my A here? What's A? Yes, A is 6 and B is what? B is 2. So my vertices will be H, which is 0, minus A, negative 6, 2. And what? H plus A, which is 6, 2. And my foci, I need to find those, which means I need to find what? C. Need to find C. What is C? C is the square root of A squared plus B squared, which is the square root of 40, which is what? 40 is 4 times 10 is 2, square root of 10. So my foci is what? H minus C. So we have negative 2 square root of 10, 2. And H plus C, 2 square root of 10, 2. Okay? Okay. Because H is 0, right? H is 0. So it's H minus A and H plus A. And A is 6. So. Look at another example. Let's just find the standard form now. Suppose we're given that the vertices are negative 2, 1 and 2, 1. And the foci are negative 3, 1 and 3, 1. This we're given. Okay. Now here they don't say that the center is 0, 0. Some of your practice problems may say that, but this one we don't know what the center is, so we can find it.
What's the second one?
2, 1. You can't what?
Well, I mean, it's obvious.
Okay, what is it? Okay, 0, 1. But still, as I said, you have to find it. It may not be obvious to some people. They may have to sketch. But you can get it from a sketch. if we sketch this thing, negative 2, 1, negative 3, 1, and 2, 1, and 3, 1 looks like this. So yes, we can find our center. It's the midpoint between the vertices, which is the point 0, 1. So HK is 0, 1. And our transverse axis is what? Horizontal. We can also see from the picture. Okay. Now we need to find A and B. Okay. Now we know that the vertices for this form is what? H minus A and H minus A and H plus A. Well, H is 0, which means A is what? 2. Right? The foci is H minus C and H plus C, but since H is 0, C is what? 3. So I can find B. Can I find B? I know that C squared is A squared plus B squared. So really all I need is B squared. Is C squared minus A squared, which is what? 9 minus 4, which is what? 5. So since my transverse axis is horizontal, my x comes first. It's x minus h, which is 0 squared, over what? A squared, which is 4, minus y minus k squared over b squared, which is 5, equals 1. And you don't have to say x minus 0. You can just say x squared if you want to. Okay?
Well, it seems like you said either way, though, x and 0 works.
Yeah, I'll accept either one.
I know in fact, when I check for answers, whatever, they always put in the next square. That's what that's doing. But now I just think I ought to go like close to the
Yeah, it does not matter to me. Next example. Suppose we're given again that the vertices negative 2, 1 and 2, 1, and that this hyperbola passes through the point 5, 4. Okay? Again, same situation here. If the vertices are negative 2, 1 and 2, 1, then that means our center HK is what? 0, 1. We can get that from the picture, okay? Transverse axis is what? Again, horizontal. Gosh, we didn't do any vertical. They must not have had many vertical. So, again, we're horizontal. Now, I can figure out A, can I not? A is 2. How do we know A is 2? From the vertices and knowing the center too, because the vertex is A units from the center, so it's 2. So I have my H, I have my K, and I have my A. What's missing? What do I need to find? B, right? I need to find B. And I can find B. Now they tell me that this hyperbola passes through the point 5, 4, which is some xy on the hyperbola, isn't it? So if I can write my standard form, x minus h squared, I know it's horizontal, so I know my a squared, my x squared comes first. If I know h and k, and I know an xy, I can put all of it in there and find b. Can I not? So let's do that. X, let's put 5 in for x. H is what? 0 squared. A is 2. Y is 4. Minus 1 squared over b squared equals 1. So what is this? 25 over 4 minus what? 9 over b squared equals 1. So I can do 25 over 4. I can bring over this 9 over b squared, and I can take over that 1. Can I not? What is 1? 4 over 4. So 25 minus 4 is what? 21 over 4 equals 9 over b squared. I can now do what? Cross multiply. 21b squared equals 36. So b squared is 36 over what? 21. 36 over 21 is b squared, which reduces to 12/7. And I don't need b, I just need what? B squared. So what's my formula? Well, what's my form? And there are two different forms. It's what? X minus h. H is 0, so x squared over 4 minus y minus 1 squared. I can say over 12/7 equals 1. It may be like this. I'll accept this answer. They may go through and take the reciprocal and say what? They may do this. I'll take either answer. Okay? I'll take either one of those. Does not matter to me. So, questions so far before we talk about something a little different? Any questions? Okay. Now, as I said before, this is the last little something that we're going to talk about in dealing with conics. And what we're about to talk about now is how we can classify conics just by looking at their general form. Now, we've been looking at standard forms. Remember, standard form is when you have to go and complete. The general form is just the what? Just the one-liner, right? You take the general form, you complete the square, and do whatever you do to get the what? Standard form. Now, we talked about parabolas, ellipses, and hyperbolas. Circles are also considered conics, but they don't get into that discussion here. But we can classify a conic from its general form. So if we have a generic conic, ax squared plus cy squared plus dx plus ey plus f equals 0, it's just a general conic. We have a circle if a equals c. Now notice we're looking at the coefficient of the x squared and y squared here. So if the coefficient of x squared and y squared are equal, then we have a circle. Number 2, we have a parabola if the product equals 0. And the product will equal 0 if what? One of them is not there. Either x squared is not there or y squared is not there, right? Number 3, we have an ellipse if the product a times c is greater than 0. Because what? We have that plus with the ellipse, right? The plus is x minus h squared over a plus y minus k. So those coefficients in front of that x both have to be positive. And number 4, we have a hyperbola if A times C is negative. And this is the case because what? This negative here. Something positive, something negative gives me something negative. So I can classify from its general form. A couple of very easy examples. Suppose I have x squared plus 4y squared minus 6x plus 16y plus 21 equals 0. What is A times C? Well, what is A? A is 1, C is 4. So A does not equal C, so we know it's not a circle. But A times C is what? A positive number, which means this is going to be what? An ellipse. A times C is positive, so that's an ellipse. Suppose we have y squared minus 6y minus 4x plus 21 equals 0. What's A times C? 0 times 1, which is 0. So this is what? Parabola. Huh? No. C goes with the y squared, A goes with the x squared. Next example, 4y squared minus 2x squared minus 4y minus 8x minus 15. What's A times C? What's A? Negative 2. And C is? So this is negative 8, which means that's negative. I have a what? Hyperbola. Last example, 4y squared plus 4x squared minus 24x plus 35 equals 0. Here, A equals C, right? So what do I have? Circle. If you have to take calculus 1, you're going to see this same stuff again. As a matter of fact, the next two little sections that we'll cover pretty much is in pre-calculus, but it's also in calculus 1 also. So the next few little lessons, you're going to be getting a preview of calculus. Okay? Any questions about what we have done today? All right, if there are no questions, then we'll pick up next time with parametric equations. You may want to read ahead, but we're going to pick up with parametric equations.